so we're going to get to doing problems today. I kind of thought we'd get to it eventually faster, but that's okay. We ended up spending more time reviewing some of the other material, which is just fine. In fact, let's just jump right into a problem here. I think we're going to do this one. Nothing like a Monday morning, just get that brain firing with the utility function. Okay, so read the problem first. Let's talk about it together on approaching it. Kind of have a little discussion about it before we just jump into solving. So read it first, and we'll look at it. Okay, so I got the whole thing down here. I got a utility function. They give you some marginal utilities. Those of you thinking about calculus, what are those marginal utilities there? Check them out. MUM equals M. MUC equals 4C. First derivatives of that utility function, right? So they're just giving them to us, but that would be where they came from. Write an equation for MRS MC. What the heck's that?
Marginal substitution using downwards.
Good. And so what's the equation? What is it the ratio of? The marginal rate of substitution. Just in general. The ratio of, not prices, marginal utilities. It's the ratio of marginal utilities. In general, graphically, what is the marginal rate of substitution? So graphically, we have indifference curves that reflect the utility function in a two-dimensional space of, what do we got here, M and C. It's the slope. So the marginal rate of substitution is the slope of the indifference curve at a particular point. Okay, so just kind of, this is all background information that's helpful to have as we approach the problems. So calculate the MRS. Based on your answers are Mariah's indifference curve's convex. I didn't talk about that convexity thing yet. I think we did mention concavity of the utility function maybe. Convexity, concavity, what are we talking about? What does convex to the origin mean? Abode in, not out. Concave is bowed out. So it's just kind of fancy math words. Our indifference curves, according to those four axioms, look like this. We're going to use math to test whether the consumer's preferences are matching up with what we expect is where we're going with part D. And so if a function is convex, we can think about how to look at its slope. If it's concave, like let's say the production possibilities frontier, looks like this, right? So we got a PPF and we got an indifference curve. What's the difference here if we were testing arbitrary points A and B of each one? What's true? What's one way to test if we're instead given a blank page with 2 points? We have 2 data points about somebody's preferences and they look like this. How would we be able to test whether this is them or this is them? No, we don't have to do that. We can use points A and B. So here we are, here's the problem. Remember, this is in the back of our minds of knowing the shapes. We expect consumer preferences to look like this, but how do we know when we're given a generic function? In other words, it could look like this, it could look like this, or it could look like this. What's different at points, mystery points A and B? The slopes. So we can test whether it's looking like this or looking like this by calculating the slope at each point. Check it out. With the normal indifference curve, what's happening to that slope as we move from A to B, which is some number of units, from 100 units to 200 units, what's happening to the slope? It's decreasing. Over here, when we move from 100 units to 200 units, and I'm just making up numbers, the slope is increasing. So we can calculate the slope at those points, potentially. Because the slope of this indifference curve is the first thing I asked for, the marginal rate of substitution. So we got that slope. Okay, go for it. Start working. Yes.
So like whenever you have the utility function, your marginal utility for that will be that derivative.
Yes, because it's a partial derivative, which treats this as a constant, and a constant term disappears, and so it's 2 times a half is 1 m.
And then for C, it'd be treating that as a constant.
Yep, then that gets treated as constant. Yep.
Okay.
So I want to stop you here for a sec. Get comfortable with this notation. M comes before C, M's on top, C's on the bottom. But talk to me in terms of our graphical analysis. Which is which? Which one's the M axis? Which one's the C axis?
The M axis is the bottom axis.
It's the bottom. So how do you know that?
Because when you were talking about kind of the change in one over the change of other, then kind of your orientation, whatever, is flipped.
It's flipped. Okay, so you're just remembering that it's flipped. That's fine. You can remember that it's flipped is one way to do it. So when I used to go through it, the memorization of just remembering that it's flipped is fine, because then rise over run is different here, right? We got a M on top, which would be kind of the rise, so you might be tricked into thinking that that's the M. But really what this expression is utility per change in M, and this is change in utility over the change in candy. Flip those over, rise over run, C's on the vertical axis, M's there, okay? So that's important, especially when you start trying to tie this back to a graph. If you're kind of comfortable with the graph from principles class, you want to be able to go back and forth.
Wouldn't it be the utility of over the change in C? Or am I-
It is here, change in U over change in C, change in U over change in M. So then you invert this and you got change in U over change in M times change in C over change in U. Cancel, cancel, rise over run.
Okay, is that different than what you have? Because you have the M over C right there on the first one.
Nope, the upstairs is the marginal utility of, what is this, a movie or a music download? So the marginal utility from music download. So this is this. Not seeing some? You guys keep working on rinsing that up.
I don't know, just
You have it flipped, but the end result would be different than what you have.
The end result is just the slope of the indifference curve.
Okay.
So the slope of the indifference curve, if we come back to this graph, now makes sense because we're rising and running a change in C over a change in M, which is the slope of our indifference curve. That's the only thing we were tying it back to. Okay? Graphically. Kind of tying together the equation and the graph. What's that?
On your slope wouldn't see on the top and on the bottom.
It is. The delta, the rise,
Right.
C is here, rise over run, and I've got C here, vertical axis.
Okay.
So I'm just tying together the indifference curve, graphical representation of the indifference curve, and what the marginal rate of substitution. There's a connection there between slope. So one of our key points from last time was that the slope, the graphical slope of the indifference curve is the marginal rate of substitution. So part B, are we on the same indifference curve? How do you calculate it? What was your approach? Plugged into the utility function. What do we know about, in order to be on the same indifference curve, what's true about utility? It's got to be same. Cadence? No, I'm just showing graphically, this is what you needed to work the problem with. So I didn't mean to confuse you. I was just trying to tie it back to a graph. The thing's not even asking for a graph all the way through. So I'm just trying to give that principles foundation work to it. So starting with this is your correct answer for A, I believe. Yeah. So here's your answer for A, m over 4c. Because all it's asking is write an equation for the marginal rate of substitution. Now B gives you 2 points.
And that's where you plug it in.
Yes. So now we just plug those quantities into the total utility function. And what did you guys come up with for utility? 10. Yep. So both answers should come out to be 10. So at m equals 4 and c equals 1, utility equals 10. And at m equals 2 and c equals 2, utility equals 10. Bingo.
So for B, you plug it back into like the original equation, the total utility?
Yes. So we're calculating that level of utility. So, go ahead.
So it asks if they're on the same indifference curve, so yes.
Right. So yes, the answer is yes, they're on the same indifference curve.
So since they have the same total utility, they're on the same indifference curve.
That's right. Because that's what an indifference curve is by definition.
Yeah, it's just
So all we've done so far is at m equals 2 and m equals 4, we found 2 points, and c equals 1 and 2. So m equals 4 and 1. We've got 1 point identified here. We've got 1 point identified here. We've successfully determined that there's some function through these 2 points that holds utility constant at 10. Then we get to part C. No, we get to be on the same different. Calculate the MRC one. Oh, the MRS. So part C is calculating the slope at those points. Which equation do you use for that? A. Good. So the slope is the marginal rate of substitution. So we're going to plug and chug back into that equation, the m over 4c. Part C. I'm going to call these a couple points here, I guess. So let's see. I'm going to call this one point B. This one point A. So we've got. Well, let me switch these. into is A. Get some colors going here. And this is point B. So plug A and B into MRS, marginal rate of substitution equal to M over 4C. What'd you find out for the slopes at A and B?
It's
1/4 at A. Okay. Slope equals negative 0.25, 1/4. And B? 1. So the MRS is 1, the slope is negative 1. So I just be thinking sometimes graphically we're thinking that. All right. Does everybody see where we're at? Do you understand how to get to there? Did everybody get to point C?
So
Or this step?
do we just remember that the slope is going to be negative, or is there?
Yes. For utility anyway, yes. I was a little sloppy here. The slope of the indifference curve is technically the opposite of the marginal rate of substitution, the negative of it. And maybe I should be more careful with technical math stuff here since we're operating at this new high performance level of econ. Okay, everybody see this so far? Yes.
We'll ask questions.
Okay, so you got the slopes. Now D comes back to where we were at the beginning. Are Mariah's indifference curves convex? No, that's right. Because it's getting steeper, right? Which is what I was kind of led off with. How do we tell functions apart? So Mariah's situation looks like this. The slope is 1, negative 1, 1 over 1. Here the slope is flatter at negative 0.25. So it's getting steeper as we move from A to B, which means there's some function here that we don't know what it looks like, but we know that it's concave, not convex. So that means Mariah is a weirdo. So D, no, indifference curves are concave, which violates axiom 4. Axiom 4 was the law of diminishing marginal utility. That's what gives us the shape that's convex. As we have more and more of a good, you'd have to give up greater, or the other one becomes more valuable to you. In terms of how much you'd be willing to give up.
So if you could still have an indifference curve that doesn't match the indifference curve?
Not really. It depends on the assumption. The model that we would be putting forward to do some sort of predictions or whatever has all the axioms in place. And so the standard situation is this one. All this is doing is kind of having you apply some math to get an understanding of why we do it in calculating the slopes and how we can determine whether it's convex or not. So it's kind of understanding the underlying fundamentals. They give you a counter argument. In the text, they give you what it's supposed to be. So then it's kind of, in theory, maybe helpful to look at a situation where it's not the same. Because on the face of it, everything worked out until we got to this last part where it's like, oh, this is messed up. So do make sure you put up here, this is messed up. Not that you messed up, but this is not a situation that reflects the type of preferences that we assume for consumers.
So then, like, in real life, what happens if you find a curve like that?
Well, then either, Good question. We wouldn't expect it on average. It would make you go back to the drawing board to see if you had some issues with your experiment or something, and you start seeing, well, maybe there's something going on here that this particular bundle is not on the same indifference curve for real. There's really some indifference curves that are looking like this, and there was a shift that were not actually on the same level of happiness. They misunderstood the survey question that said, what bundle makes you feel the same amount of happiness? And they screwed up. So it's an outlier, we throw it out. Okay, possibly. But it certainly opens up more questions for you, the person to be thinking about. Okay, anything else on that one? Let's get the budget constraint here. So budget constraint is our income and prices. So Braden has $20 per week that he can spend on video game rentals, priced at $5 per game, and candy bars priced at $1. Write an equation for Braden's budget constraint and draw it on the graph. Draw it on a graph that has video game rentals on the horizontal axis, so they even told you where to put what. So this is kind of some basic stuff. This is principles level stuff of budget constraints here. Budget constraint, generally a line or a curve? Line. So it shows our affordable bundles. There's our basic budget constraint. Might be helpful to just do plug and chug on your graph. I don't think they necessarily give you direction. So if we blow our 20 bucks on rentals, how many can we have? 4. So that's the way I like to think of it. Blowing your whole income on one good or the other basically sets the stage, easy way to set the stage for the budget constraint graphically. You could convert this to slope-intercept form, right? So slope-intercept form, whatever's on the vertical axis, you need to throw over to the left-hand side. So if we solve this equation for C, and put it into slope-intercept form, we could have C equals 20 minus 5R. And then we'd see that the vertical intercept is a 20, horizontal is 4, everything in between. So nothing tricky there. Anybody have any questions? What'd you get at 3? At 3 units of utility. 5? Good. So 3 video games gave you a 5. A couple different ways, plug and chug equation, plot. What happens to the budget line when the price of video game rentals falls from 5 to 4? Swings out. So 5 to 4 allows us to buy an extra one. Budget line swings out. Now, there's a couple things that this problem doesn't necessarily point to directly. Slope of each budget line. So if we call this B1 and this B2, what's the slope of each? -5, -4. So -5, -4. And what's that always equal to? No, not the marginal rate of substitution for budget line only. In equilibrium, it ends up being equal with, once we add indifference curves. Slope of the budget line. Slope of the budget line. This is the budget line. So the slope of the budget line is equal to, it's equal to -5. What is that? Nope, no indifference curves here. Go back up to this equation and tell me what it is. Go up a level. Don't go with the numbers.
The price of the x-axis.
Yes. Yep, that's the price ratio. So if we solve this, leaving the p's in place here, we get C is equal to I divided by the price of, it just so happened that the price of candy was only $1, so it was a little bit not in your face in this one. So it's I over the price of candy, that's where the 20 came from, minus 5, which was the price of rentals, over the price of candy times the quantity of rentals. So this is an important equation to remember. It's the slope-intercept form of the budget equation. That might be helpful in some other problems where we start to go back to, maybe you guys wanted to bring in the marginal rate of substitution. Well, in equilibrium, this is called the price ratio. Or you can also think of it as the relative price of what? Is it the price of candy or the price of rentals? 5. Candy. So you gave up 5, the price of candy is 5 rentals? Or is the price of a rental 5 candies? Price of a rental is 5 candies. So again, this is kind of, this catches you on the slope thing is weird again. So the relative price of a rental, which as Chelsea was pointing out, is the horizontal axis variable. Notice it's on the upstairs, not the down. And similar to what this little trick is that's saved me many times on many exams and homework, you can do the same thing with this price ratio. So the price of rentals over the price of candy can be thought of as a certain amount of dollars for every rental. Dollars per rental, dollars per candy, dollars per rental times candy per dollar, dollars cancel, candy over rental, rise over rent. Or memorize that they're flip-flopped always. The price of the horizontal axis variable is always on top, and the other one is on the bottom. Now, first of all, let me pause there. So questions on that? Now let me get to Rianne's point. What happens in equilibrium between the marginal rate of substitution and the price ratio? We learned that one in principles. It's our first order condition. They should be equal. So we know that the consumer's maximizing utility when the slope of the indifference curve is just kissing 1 point on the budget line. All right, so let me do a little recall action here. There's an infinite number of indifference curves for a particular consumer. So there's an indifference map. I picked out 1, 2, 3, 4, 5, 6, but there's actually an infinite number of them, right? And the further away we're away from the origin, the higher the level of utility. More is preferred to less. And so we want to kind of think about imagining like you're pushing out the indifference curve, but they're all there anyway. You're just trying to maximize your happiness by being on the one furthest from the origin. Well, once we bring a budget constraint into the picture, whatever it looks like, what is our maximum level of happiness? How do we get it? Well, we choose an amount of markers. I didn't want to, oh good, I didn't do that. Markers and bananas, such that we're on the highest level of happiness given our preference structure. And so presumably there's another one in here that comes down and just kisses that one. That indifference curve is the highest level of happiness I can be given market prices that make up this indifference curve. And so my optimal quantity of markers and bananas is right there. And at that point, the slope of the budget line equals the slope of the indifference curve. If we strictly stick to equation goggles, the slope of the budget line in my marker banana example here, the price of whatever's on the horizontal axis goes on top. The vertical axis variable goes on the bottom. Those two things have to be equal. The marginal utility, same little trick works with the indifference curve. The marginal utility of markers over the marginal utility of candy. Bananas. Let's see what we got. So we've got Antonio getting his utility from consuming burgers and fries according to this utility function. Utility equals the square root of burger times fries. Or they did the math for you and they showed the equation as each one raised to the half power, which is a legitimate math move if you got that square root. So let's read the equation again and then discuss our approach. Where B is the amount of burgers he eats, fries is the amount of fries. Antonio's marginal utility of a burger, they give that to you. Again, that would be the partial derivative of each quantity of that utility function. Antonio's income is 20. Price of burgers and fries are 5 and 2 respectively. What are Antonio's utility maximizing quantities of burgers and fries? What's your approach? Income? Budget line? What else? In general, what else is your approach? Why are you doing this? What are you ultimately trying to get to? The slope of what?
The
if you're using this equation. If you jump to this equation, you're looking for the slope of the budget line. And then what else do you need? Slope of the indifference curve, right here. This is what you guys are going for. Figure this out. Here's going to be something related to the budget line, like you were saying. This is something independent related to the utility function, but we got all this. All of that's given to you in the problem. So set that. This is the condition to maximize utility. This condition must hold. This is the utility maximizing condition. It's called the first order condition, a little more formally. First order in the sense that this is the slope of the indifference curve, this is the slope of the budget constraint. It's a first derivative, it's the first order condition to utility maximization. We know that that has to be true at the equilibrium quantities. So calculate this, set them equal to each other, and go. Is restate the space. This was with markers and demand. Hairy, isn't it? Getting fun. So marginal ratio of the marginal utilities. This is the marginal utility of. I keep wanting to say beer, burgers. So you got this part. Okay. Is everybody clear with getting to this part?
Why are the two equations on top of each other?
This is the marginal utility of burgers, which was given to us in the problem. This is the marginal utility of fries. It's kind of complex and complicated, but that's all we're doing is we're putting one on top of the other. And then we say a prayer. A prayer for simplification. I made many of those prayers. I want you guys to get to this point. So what happens next? Yeah, That's a prayer for simplification might be coming true here. Deep, heavy prayer for simplification. We might get it. What does it equal? How do we solve exponents in what's that? You subtract them. Right?
So you just get
So what do you get? So first of all, let's take care of this little guy up front. What happens to the little 0.5? Cancels. It's gonzo. So then we got b to the negative 0.5 minus 0.5 equals b to the what? B to the negative 1 times f 0.5 minus a minus 0.5 gives me f to the 1 power equals 5 halves. Help me with this here. B to the negative 1 power could be expressed as 1 over b. So, and f to the 1 power, do we need to write that 1? No. So we get f over b equals 5 over 2. Our prayer for simplification worked. So f equals how much? 2.5 burgers. So f is a function of burgers. Sam, you're being a bit quiet. You good with this?
Not really.
Digesting, sitting in?
Yeah.
What troubles you the most? The exponent stuff?
Yeah, and the slopes and all that.
Okay. So this type of stuff, you need to review the principles material. This is principles level stuff here of slope of the indifference curve equals the slope. So again, on a graph like this, somebody's indifference curves might look like this. And so they maximize utility at this quantity. So at the profit maximizing quantity, have memorized that this is what goes on. The slope of the indifference curve equals the price ratio. Slope of the indifference curve equals the slope of the budget line. That's it. And that's how we get the optimal level of whatever these goods are. Here we had, I can't remember, R and C, rentals and candy. And those would be the quantities that would maximize utility for this consumer over here. For this consumer now, we've now got an equation that shows the relationship of food and burgers at the optimal quantities. But we want to actually solve for these quantities. So help me out. What can we do with this? We need to take this to another step. Step number 2. How do I want to know an actual quantity. We have enough data here to get the actual quantity, not a functional relationship. But is this guy eating 10 fries and 6 burgers, or is he having, you know, what's he doing? Look at your equations. Tell me where we could deduce that. Plug it back into the budget line. You got it. So now plug, let's call this equation star. Plug equation star into the budget line. And depending on how you wrote that, the budget line was equal to 20 times, what was our prices here? 5 and 2, right? So price of burgers are 5, so it was 5 times B plus 2 times F. And we got 2 equations, 2 unknowns. We can solve this. So sub-equation into the budget line. And what did you get? 2. So after you do all this, B equals 2. But that's not the complete answer yet. And fries equal 5. So, and that's really kind of step 3, I guess. It's a little tiny baby step, but we solve for burgers. So B star equals 2, the optimal quantity of burgers. Let's call this equation double star. So now sub double star into star, and we get fries equals 2.5 times 2, 4, 5.
So is it just coincidence that our ratio came out to be 5/2?
Totally. Totally coincidence. So if we were to graph this baby, we can, we've got a slope of 2.5, whatever that would look like. We weren't required to graph this at all, so we're done with the problem as far as the exam or homework goes. We weren't asked to do this, but just so we kind of recap things here. We've got fries measured here, burgers here. We can draw this specifically, but we have an indifference curve where we were at B equals 2 and F equals 5. B star and F star. Okay?
If you had this on a test and you asked us to graph it, would you worry so much about the slope
Nope.
of our indifference curve?
Nope. Well, depending on what I'm asking. If I asked you, if I gave you graph paper essentially and said I want you to graph this specifically, but what this class is all about is really staying in that equation realm for the most part. I want you guys to tap back. I'm kind of using the graphs to kind of go back to principles and tie this all together so that in your brain, your intuition needs to stay strong. And I feel I'm a strong believer in having strong economic intuition. And so my brain tends to work with the equation or with the graphs, and I can deal with equations, but that's how I see them working in harmony. Did I see another question? Yeah, Chelsea.
I mean, you know this is kind of like, is there a double check for that you, when you get the B and the F, is there like a...
Yes, you could,
Is there another equation that you plug it into to double check?
yeah, if you plug it into here,
Oh.
you could plug that B and the F into there, and you should get 5/2,
Oh.
right? So if you take the MRS equation, yep. All right, so Wednesday, chapter 4 homework. I don't know if you guys know, but classes are canceled for Friday. So that'll give you an extra long time. We'll talk on Wednesday.